we will talk about operation on real number. Let's first take rational numbers. Rational numbers satisfy commutative law. What is commutative property of addition and multiplication? That means if you take any two rational numbers, say a and b, then you can say a plus b will be same as b plus a. So this is commutative law of addition. For any two rational number, you can see one example like 1 by 2 plus 1 by 3 will be same as 1 by 3 plus 1 by 2. And this is called commutative law of addition of rational numbers, right? Commutative law of addition, you can say. We also have commutative law of multiplication that will say the product of two rational numbers. Let us take any two rational numbers, say 2 by 3 into another rational number 3 by 4 would be same as 3 by 4 into 2 by 3. So this is commutative law of multiplication. The product on the right hand side will be same as the product on the left hand side. Then we have associative law. If you have three rational numbers, let us first write in terms of a, b, and c. So what we want to say is a plus b plus c will be same as a plus b plus c. So associative means whether we put bracket in the first two or we put bracket in the last two, the addition, the overall sum of these will be same. We can take an example here, like if you want to add 1 by 2 plus 1 by 3 plus 1 by 4. You want to first add 1 by 2 and 1 by 3, and then the sum of these two numbers, you want 1 by 4. Or you take 1 by 2 separate and you first add 1 by 3 plus 1 by 4. In both cases, you will get same answer on the left hand side as well as right hand side. So that is associative law of addition. Similarly, you have associative law of multiplication also, where you take three numbers and you say a into b into c will be same as a into b into c. Whether you multiply these two first, then the product you multiply with a, or you multiply these two first and then product is multiplied with c. In both the situations, you will get same answer. That is called associative law of multiplication, right? You can take any example of rational numbers and then you will find that in the both cases, you are getting same number, same answer. Then we also have one distributive law. What are distributive laws? Suppose you have a and b and c, three number, right? A multiplied b plus c. If there is no sign, that means it is multiplied. This would be your a will get multiplied with b first, and then a will get multiplied with c. So we would like to write it as a into b plus a into c. This is called distributive law of distribution of multiplication over addition. So similarly, if you have a into b minus c, let's take another example. A, b, c are any three real numbers, then your answer will be as per this. A gets multiplied with b and the minus sign is there, it will remain here, and then a gets multiplied with c. So this is called distributive law of multiplication over addition or subtraction. So what we learn is the rational numbers are commutative, they are associative, and they are distributive for addition and multiplication. Now, let's see what about irrational numbers. Irrational number also follow or also satisfy the commutative, associative, and distributive law of addition and multiplication. Let us see what we mean. Suppose let's take two irrational number. Let's say under root 2 plus under root 3. This sum will be same as under root 3 plus under root 2. Just like rational number, irrational numbers are also commutative in addition. Now, not only in addition, in multiplication also, let's see the same example. Under root 2 into under root 3 will be same as under root 3 into under root 2. In both cases, we are getting root 6, root 6. Both the answer is root 6. Now, what we observe that even irrational numbers are commutative for addition and multiplication. Let's see whether they are associative also. They are associative as well. Let's take an example. Suppose we multiply under root 2 with under root 3 plus under root, let's say associative law of addition first. What we want to say is under root 2 plus under root 3 plus under root 4. These are three irrational numbers. Under root 5, let's take, would be same as under root 2 plus under root 3 plus under root 4. We just want to put bracket in the first two or last two. In both situations, we will get the same answer. We are simply adding these numbers, right? So that means they are associative. Addition of irrational number is associative. What about multiplication? Interestingly, multiplication is also associative. Means if you have three irrational number, let us simply write them in terms of A, B, and C. A into B into C would be same as A into B into C, where A, B, C are irrational number, and you put bracket over there or you put bracket over here, will be same. Let's see about distributive laws. Let us take an example here. Suppose you want to multiply under root 2 with under root 3 plus under root 5. Now, the distributive law says you will multiply this root 2 with root 3 and then root 2 with root 5. So your answer would be, this would be equal to, this should be equal to root 2 into root 3 multiplied and then plus in between root 2 into root 5. This is what we call distributive law of multiplication, right? So similarly, we can also write another example, right? Say if you have root 2 and there we have root 3 minus root 5, just like the real number, we can also write here root 2 into root 3. Root 2 gets multiplied with root 3 first, and then minus root 2 gets multiplied with root 5. So this is called distributive laws for or distributive laws of the irrational numbers. I mean, irrational numbers satisfy distributive law of product over addition or product over subtraction. Okay, so what we have seen is now these basic rules, what we have, the commutative, associative, distributive, and multiplication, distributive laws are satisfied for rational as well as irrational number. Now you'll move on to the next thing. Rational numbers, whether are closed, as we know, the rational numbers are closed. What does it mean? When we add two rational numbers, we get a rational number. When we subtract two rational numbers, we get a rational number. When we multiply or divide two rational number, again we get rational number. So when you're doing any operation of addition, subtraction, multiplication, or division among rational numbers, you are getting rational number. And what does that mean? It means rational numbers are closed. It means rational numbers are closed. Whenever you multiply two rational numbers, you get a rational number. You add two rational number, you get rational number, right? So they are closed. But in division, when you divide any rational number by another rational number, you cannot take zero in the division, because zero is also a rational number, but we will not consider division by zero simply because division by zero is not defined. So that's why we have taken this, we have written this except by zero. So we will not take zero there. All right. So this is it. Rational numbers are closed. I mean, we would like to now see whether irrational numbers are also closed. When we take two irrational number, what happens to the sum, difference, quotient, product, and irrational number? Are they always irrational? They are not always irrational. You just simply take two irrational number. Let's see some example. Let's take under root 2 plus under root 3. Under root 2 is it's a decimal. Expansion will be non-terminating, non-repeating. Under root 3, like it will be 1.41. It will keep coming, right? And root 3 will be like 1.73. And then some number, strange pattern will keep continuing. When you add these two numbers, then obviously you will get irrational number, right? So root 2 plus root 3 is giving you what? Irrational number. But it is not always true. Take another example. If you add under root 2, which is an irrational number, you add this number with minus of root 2. In this case, you get 0, which is a rational number. So irrational plus irrational can give you rational also. It can give you irrational also. Means when we add two irrational numbers, we can get a rational number. We can get irrational number also. So that means irrational numbers are not closed under addition. Similarly, we can show that the irrational numbers are not closed under multiplication. Let us see, if I multiply under root 2 and under root 3, we get under root 6. Okay. It looks like irrational multiplied with irrational, we are getting irrational. Irrational multiplied with irrational, we are getting irrational. Looks like it should be closed, but it is not, because we see another example just then, like under root 2, which is an irrational number. When we multiply this with 2 square root 2, right? Both are irrational. See, this is irrational. This is also irrational. What product we get? 2 into root 2 into root 2 means 2 into root 2 into root 2. Look, under root 2 into under root 2 will be under root 4, which is 2. So that is 2 into 2, which is 4. Oh, we got a rational number. So the product of two irrational numbers can be rational also. This is very interesting. Two irrational number multiplied can give you both rational as well as irrational. That means product is also not closed. Product of irrational number is also not closed. So whether it is sum, a difference, product, quotient of two irrational number can be either rational or irrational. So we can say that irrational numbers are not closed. The operation on irrational numbers are not closed. Now, we would also like to see what happens when we add, subtract, divide, and multiply a rational number with irrational number, right? 2 plus under root 3. What do you expect? What would be the answer? A rational number 2, irrational number would be 1.732. It continues I mean infinitely, never ending number, never repeating number. So when we add these two numbers, we get 3.732, and that part will continue forever. That means we are getting irrational number. Means whenever we add a rational and irrational, that is very interesting. Again, a rational plus irrational number will always give you irrational. Similarly, a rational minus irrational will also give you, from the same example you can understand, that will also give you irrational number. Now consider what happens when we multiply a rational number with the irrational number. Let's take the same example and multiply 2 with under root 3. We get 2 root 3. Is it rational or irrational? As you see, root 3 would be 1.732 blah 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 continues, no? So when you multiply this with 2, you do not expect these digits to terminate. There will be some number like that. So that would be irrational. So this number would be irrational. So a rational number multiplied with irrational number will give you irrational number. So we can say rational plus irrational, multiplied. Rational multiplied irrational would always be irrational number. Similarly, we can say whenever we divide a irrational number by rational number, for example, we divide root 2 is a rational number and 2 is a rational number. So do you expect to get a rational number? Of course not, because the numerator is irrational. When you divide an irrational number by 2, that division will keep continuing for infinitely long. So that is also a irrational number. Now, what if we divide a rational number, say 2 by root 2? Again, see 2 by root 2, look, you can rationalize the denominator, right? Root 2 by root 2. That will become 2 root 2 divided by 2. Again, an irrational number divided by a rational number. So you are getting a rational number again. So what did we observe? Whenever we take one rational and one irrational number, whether you add or subtract, you get irrational number. And whenever you take a rational and another irrational number, you multiply or divide, whatever you do, then also you are getting irrational number. Means all these 4 operations of addition, division, multiplication, and subtraction with the rational and irrational is always giving you irrational number. Having said this, I would like to ask you a question. Pi is defined as the ratio of the circumference. Look, the definition of pi. Pi is a beautiful number pi, right? Which is defined as circumference divided by diameter. Okay, or we can say in short, pi is equal to C by D. Pi is equal to, as a formula, we can say pi is equal to circumference by diameter. Okay. Now, we know what is the circumference of a circle. Let's draw this diagram, and let's also draw the diameter. Diameter is a line segment passing through the center. Here it is. Does it look like diameter? It should look like as if it is passing through the center. Yeah. So here somewhere would be the center. Now this is the diameter AB. Let's say AB is the diameter and this is the circle. When we say circumference means this distance, the distance along the boundary of the circle, known as circumference. So suppose we measure this circumference by some measuring device and we find it that it is, say, 44. Okay, 44 meter or centimeter or whatever scale you use with. And diameter, for instance, let's say it came out to be 14. We just measured this diameter also, it came out. Now 44 by 14, it looks like it is 22 by 7, right? Which is in the form of P by Q. Okay, that is the question. Which is in the form of P by Q. This should be irrational. Then why we are saying pi is irrational? Right? Can you answer this?